Hi, my name is Dr. Igor Tabrizian. I'm a qualified medical doctor with a background in integrative and preventative health. On this channel, I'll explore evidence informed approaches to optimize well being from nutrition, gut health to hormones, energy, and everything in between. Please note, this information I share is general in nature and not intended to be used as medical advice. Always consult your own healthcare professional before making any changes to your health routine. Welcome to the nutrient stream. Well, let's first of all define what a nutrient is. So, a nutrient is something that is required for an organism or a system to survive, replicate, and carry out its functions. When it comes to mammals, some mammals can make more of their own nutrients, but sometimes they need more external sources. For instance, if you take an 80 kilogram goat, that goat can synthesize if you take an 80 kilogram goat, that goat can synthesize 13 grams of vitamin C every day because it still has the enzyme that can convert glucose to vitamin C. But an 80 kilogram human apparently can survive on 62 milligrams of vitamin C per day. Obviously, there's some controversy about the amounts, and this has been like it for some time. But when that 80 kilogram goat is stressed, it will make 100 grams of vitamin C per day. So I'll leave it to the listener to decide for themselves whether the general consensus that 62 milligrams of vitamin C per day for all humans under all conditions long term is actually rational and scientific. Well, coming back to nutrients, most nutrients will come from the environment. So, for instance, when you eat beef, which contains vitamin B6, the B6 actually originated from the plant that the cow ate. Now, some ruminants can make their own B vitamins if they have enough of all of the components for them. For instance, a cow's microbiome will make vitamin B12 as long as it's supplied with enough cobalt. And this is one of the reasons cows get cobalt supplements, so that they make sure they will always have enough vitamin B12. Whereas humans have certain limitations for what nutrients we can supply ourselves, we are basically reliant on our environment and our microbiome, and the more we study the microbiome, the more we realize how delicate that situation is. Just to be clear at this point, though, a microbiome cannot synthesize minerals. It can only make vitamins, cofactors, neurotransmitter precursors. The minerals all come from the topsoil or fertilizers. So really, the amount of nutrients produced by a microbiome is an adjunct to the diet. Very few animals can survive completely on nutrients Very few animals can survive completely on nutrients synthesized by their microbiomes. Another feature about nutrients is that eventually they're broken down or recycled. The minerals stay intact, although their electrical charge might change. So let's take glucose for a minute. A plant will produce glucose from carbon, oxygen, and hydrogen. Then we ingest that glucose and then we break it down to carbon dioxide and water while we extract the energy from the bonds between the oxygen, hydrogen, and carbon. More on this in another episode. Then how do we get rid of those byproducts and stop ourselves from blowing up from the soda water? Well, the water and carbon dioxide are combined to make an acid called carbonic acid. And that is secreted into the bloodstream, and the blood will courier that to other organs for excretion out of the body. So when the carbonic acid gets to the lung splits it back into carbon dioxide and water, and we exhale the carbon dioxide and water and send it back to the atmosphere. When the carbonic acid gets to the kidney splits it in a different way into hydrogen ions and bicarbonate and excretes them as electrolytes into the urine. And this will affect the pH of the urine, which can be measured by a dipstick, a common urinary dipstick. When the carbonic acid reaches the stomach, the hydrogen ions are pumped into the stomach lumen. This is the proton pump that does this. And some of you might have heard of a class of drug called proton pump inhibitors. They stop the hydrogen ions being excreted. And then when we split the carbonic acid to the hydrogen ions and then the bicarb is used to make the zinc bicarbonate gel that lines the stomach to protect it from the very low pH. If you think about it, if the stomach acid pH is 2 and you put that on your skin, you'd burn a hole in it. So what protects the stomach lining from that extreme pH? It's a buffer that lines the stomach. It's got a grey appearance that reflects back on the endoscope. Now, our breathable air is mostly nitrogen. And when we get this into our bodies as amino acids, we do that when we eat protein. So in carbohydrates, the hydrogen, carbon, and oxygen have a connected exit strategy, but the nitrogen has to leave in a different way. We can't let nitrogen just build up and up in the body. So for this pathway, we use a thing called the urea cycle. So we make urea from that nitrogen. If you ever had your kidney function tested, you'd notice that urea is measured. Now, farmers use urea powder to apply nitrogen to their crops. So that's how we excrete nitrogen that we get from our food. Nutrient flow, therefore, is from the environment into us, and then excretion is back to the environment. Some nutrients like coenzyme Q10 or ubiquinone are produced by some plants like spinach, but the stronger sources are probably animal flesh, because the CoQ10 is found in the mitochondria, which is how muscle is powered. Its discovery in 1957 actually was from beef heart muscle, and that contains a lot of mitochondria which house the coenzyme Q10. But what's interesting is 28 years earlier, the cartoon character Popeye, first shown in 1929, depicts Popeye eating spinach to boost his energy. This highlights a general pattern in science that belief always precedes explanation. There is some evidence also that the E. coli in our microbiomes make coenzyme Q10 for us. This is one cofactor we also make from carbon molecules, from 2 carbon and 5 carbon. We add them together to make a 5, and we join the 2 5s, and that's the 10 part of the CoQ10, but more on that later. It's still not the end of the story, though, because ubiquinone needs to be converted to ubiquinol, which is the active form of coenzyme Q10. And some people do not have a very efficient conversion process. It's a gene called NQO1. So in that case, for people who are really requiring CoQ10 for energy, they're better off to be taking the ubiquinol form. Now, minerals, unlike cofactors and vitamins, cannot be created from plants or any other source. The only sources we have are from topsoil or from the ground. So the 2 major sources actually are in the ground, like mining deposits or the topsoil. I'll give you an example of the disparity of this. In Australia, zinc levels are very low in our topsoil and have to be added by farmers. But Australia has one of the largest zinc mines in the world. It's up near the Gulf of Carpentaria, and it's called the Century Mine. And I believe it's called that because you could mine it flat out for a century and still not run out of zinc. So this is the type of disparity that we have. The WHO estimates that about 17% of the whole population of this planet is deficient in zinc. There have been various paradigms over the years looking at the importance of mineral levels and the ratios in the soil. Probably the most famous is by an American doctor called Dr. Albrecht. And there are some farmers in Australia, definitely in the US, who use the Albrecht method of soil analysis. And he said if you got the ratio of calcium, magnesium, sodium, and potassium right, in the soil, you have better health of the humans that were eating the food off that soil. But there'll be more on this later on, so thanks for watching.